In the realm of cosmic exploration, the lambda cold dark matter, lambda CDM model, our long-standing celestial Bible, may be on the brink of obsolescence. This model, responsible for numerous Nobel laureates and our understanding of the cosmos, is now facing a potential overhaul, thanks to a groundbreaking telescope, the Webb Telescope. Launched just a few years ago, the Webb Telescope has been venturing deeper into the universe than any telescope before it. Its findings have left astronomers scratching their heads, with thousands of bizarre objects spotted in the furthest corners of the universe. These ancient and distant galaxies are behaving unusually, defying the expectations of our current theories. The twist comes when these galaxies are peered past the so-called dark ages of the universe, a period immediately following the Big Bang, traditionally believed to be a time of quiet and uneventful cosmic evolution. Instead, the Webb Telescope discovered complex structures and massive objects that shouldn't have existed yet if the universe is only 13.8 billion years old. This isn't a simple glitch in the data. Some of the brightest minds in astrophysics, including Nobel Prize winners, are beginning to question the early universe's appearance. In fact, some are pondering a jaw-dropping idea. Could the universe have had no beginning? What if these distant galaxies we thought were part of the early universe are, in fact, something else entirely? The lambda CDM model suggests the universe is made up of cold, dark matter and mysterious, dark energy. The early galaxies, according to this model, shouldn't have been able to get that massive so quickly. To reach the size of what the Webb Telescope is seeing, they'd need to suck in all the ordinary matter in the universe, and even that wouldn't be enough. The math simply doesn't add up. So, what exactly did the Webb Telescope spot? Way out on the cosmic frontier. And why are so many scientists saying this changes everything? Let's rewind to 1929. That's when Edwin Hubble discovered that galaxies are all moving away from each other. Space itself is expanding, stretching like cosmic taffy. But here's the mind-bender. This expansion has no center. No matter where you stand in the universe, it feels like everything is moving away from you. It's like being the center of your own personal universe. And so is everyone else. And it's not just expanding, it's speeding up. Galaxies farther away are accelerating faster than the ones nearby. Imagine you're standing on Earth, looking out through the Webb Telescope. What do you see? A universe where everything is racing away from you. Galaxies disappearing into the cosmic distance. The farther they are, the faster they go. Sounds like science fiction. Nope. Just everyday mind-blowing astrophysics. You probably know that galaxies are moving away from us, and the farther they are, the faster they're speeding off. That's not just some quirky fact. It's one of the pillars of modern cosmology. Now here's where it gets wild. There's a region out in space where galaxies are racing away from us at the speed of light. Scientists call this boundary the Hubble sphere. Makes sense so far, right? But hold on, it gets weirder. There are galaxies beyond that Hubble sphere that are actually moving away from us faster than the speed of light. And here's the part where your common sense might throw a red flag. Wait a second. If something's moving away faster than light, shouldn't that mean we'll never see it? Sounds logical, right? But nope, that's not quite how it works. Believe it or not, we can still see some of those galaxies, even though they're technically outrunning light. How? It all comes down to the fact that the Hubble sphere itself isn't fixed. It's expanding, just like the universe. So, as space stretches, it actually pulls more of these superfast galaxies into our visible reach. We're talking about galaxies whose light is somehow still catching up with us across cosmic time, kind of like light riding an escalator that's growing longer as it goes. Now don't get too excited. We can't see forever. There is a boundary to how far we can peek into the cosmos, and that's what scientists call the observable universe. Imagine a giant bubble around Earth, about 92 billion light-years wide. Anything inside? We can, in theory, detect it. Anything beyond? That's where things vanish into the cosmic unknown. And if you look right to the edge of that bubble, what do you see? Not stars, not galaxies, but a faint glow, called the cosmic microwave background radiation. It's like the universe's baby photo, a snapshot from just a few 100,000 years after the Big Bang. Here's another jaw-dropper. The most distant galaxy we've ever spotted is called Jade's GS Z14. This ancient light comes from a time when the universe was only about 290 million years old. Think about that. We're seeing this galaxy not as it is now, but as it was, basically a cosmic toddler. And here's the kicker. By now, that galaxy, it's long gone from our view. It's drifted beyond the observable universe. Whatever it is today, maybe a cluster of galaxies, maybe nothing. We'll never know. Its light will simply never reach us again. Now let's zoom out one more level. There's a lot more universe beyond what we can see. Galaxies, stars, entire regions of space, out there, somewhere. We just can't observe them. And that edge we talk about, it's not the edge of the whole universe. It's just our observable limit, Earth's viewing bubble. For an alien species living 50 billion light-years from us, their bubble is totally different. Now, you might have heard the classic tale that the universe started from a single point, a tiny, dense spot called a singularity. Sounds dramatic, right? But that's not the whole picture. Because if the universe is truly infinite, and a lot of evidence says it is, then it's always been infinite. That means, Big Bang didn't happen in one spot. It happened everywhere, literally everywhere, at once. Okay, let's take a step back and think big, like really big. You know how we used to believe the first galaxies popped up in specific regions of space? Kind of like cosmic cities forming on a blank map. Well, that idea might be out the window. It turns out those first galaxies, they didn't start in one spot. They showed up everywhere, not just in our corner of the universe, but even beyond what we can see, past the edge of the observable universe. It's almost as if, at a particular moment in time, matter just appeared throughout the entire cosmos. And that faint glow we detect from all directions, the cosmic microwave background. That's the first light of matter, the afterglow of a universe being born, reaching us from all directions in space. That's what the standard theories tell us. That's what we've been working with for decades. But here's where it gets exciting. The Webb telescope might be turning all of that on its head. So the plan was simple. Point the Webb telescope deep into space and see what the first stars and galaxies looked like at the very edge of the universe, right? Easy enough. But when astronomers did just that, they didn't see what they expected. Instead of faint early galaxies slowly forming, they found bright, strange objects, things that didn't fit any known model. And that wasn't just a fluke. Scientists kept digging and found more and more of these cosmic weirdos. In fact, a recent study published in the Astrophysical Journal revealed something jaw-dropping. Researchers identified 87 potential galaxies that could have existed only 200 to 400 million years after the Big Bang. Yeah, that early. And here's why that's a problem. According to the lambda CDM model, the universe shouldn't have had enough time or material to make that many galaxies that fast. One of the study's authors, Hao Jingyan, summed it up perfectly. He basically said, even if a few of these galaxies are confirmed to be real, it would mean we seriously need to rethink how galaxies formed in the early universe. And wait till you see this. The Webb telescope captured a stunning image of one such ancient galaxy, and it doesn't look anything like the galaxies we know. Usually, galaxies are a mix of gas, dust, and stars. The gas is key. It's what forms new stars over time. But here's the shocker. In most galaxies, only about 10% of the gas gets turned into stars. The rest stick around, doing galaxy stuff. But in this new batch of galaxies from the early universe, the Webb's data shows 100% of the available material was turned into stars. All of it. Every atom. No leftovers. That's not just unusual. That's supposed to be impossible, according to current physics. Our cosmological models say galaxies just don't do that. Not ever. So naturally, scientists are freaking out a bit. Some are wondering, are these even galaxies? Maybe we're looking at something totally new, some unknown class of objects that doesn't fit into our current understanding at all. And what if they are galaxies? Then we've got a bigger problem, because that would mean the Big Bang model itself might be incomplete or even flawed. It couldn't have created fully formed galaxies like these so soon after the beginning of time. Not under the rules we thought we understood. So what are these mysterious objects? No one knows for sure yet. But one thing's certain, the universe just got a whole lot more interesting. All right, that's all for today's deep dive into cosmic confusion. Let me know in the comments what you think these strange objects might be. Something completely new. A crack in the Big Bang theory. Or maybe just misunderstood data. A Nobel Prize winner says the Webb may have found another universe. Yep, it's getting weird out there.